Good morning, everyone. Welcome back to Data Programming 1. Before I go ahead and get started talking about lists, let me just first say how sorry I am about all of the problems that happened with our exam. It wasn't just our class. It was pretty much all of the UW system. Not just our class, not just Madison, but every UW school in Wisconsin. The atomic assessments tool went down. It just couldn't handle the load, and we'd been working with them ahead of time. We knew there were issues with the quizzes, and they scaled up their system. They added more servers, and we didn't think it'd be a problem. Turns out it was. I know how stressful it is. You need to take an exam, you open it up, you get a 503 error, or you click submit, and it doesn't seem to be working. It doesn't submit. The clock is running out. I know that's stressful. Whenever that happens, definitely write to me. Write to Mina, whoever, an instructor, a TA, and we will help you out. These are problems that we can work with. And I know they're stressful, but I don't want technical problems to ever influence your ability to do well in the course. So I apologize once again for that. And we still have students who are dealing with these technical issues and have not yet taken the exam. We've just given them extensions or additional tries. If you're one of those students, make sure you go ahead and continue working on this as quickly as possible. For everyone else, please do not post questions about the exam on Piazza. If you got something wrong, you want to know how it works, you think, wow, the exam's over, now it's safe to post, please don't do that yet. There will be a moment when everyone's finished, and then we'll take questions about how the exam works. Don't post them on Piazza. Feel free to go to office hours and visit with one of the TAs and discuss how things work there. All right. Before I dive into lists, I also want to just quick jump over to Python Tutor and talk about one more kind of loop. So at the end of this, we're going to have 3 different kinds of loops that we'll be able to use. I've just got a silly example. I'm just going to print out PPP, YYY, TTT, HHH, OON, NN. It's kind of hard to say. An easy way to do that, and the simplest kind of loop we have, and to be honest, the one that you will probably most frequently use, is just the regular for loop. And this is the iterator style for loop. I'm not sure it's got a better name than that. But anyway, what we're looking at is in this case, I'm going to be looking at something in something. And you can think about this as this is my data, and this is one piece of my data. All right, and then I'm going to be doing something with one piece of my data. Okay, so in this case, what I'm going to be looking at is actually the string Python, just all 6 of those letters. And I'm going to be going through this data, a string of characters, a sequence of characters, and grabbing one character at a time, printing it out on its own line 3 times. So in that case, I'm just going to, because I'm looking at characters, I'm just going to call it C, short for character. Then we'll print it out. Print C. All right, so when we do this, I've got my output window over here. I can see I get each character 1 time. Now, to make it happen 3 times, I can just multiply the character by 3. And that's going to give me the exact effect I want. So this is the first style loop. It's the shortest, it's the most concise, very focused, great for going through data. And we'll see that not just strings, but the topic for today is lists. We're going to be going through lists of data using loops that look a lot like this, where I'm just grabbing one piece of the data. Okay, I'm going to leave this up here, but the next thing I want to talk about is another kind of list. For loop. This is going to be the range for loop. And let me just real quick demo how this works, and then I'm going to talk more about range. For in this case, I'm going to have for something in something, because it's a for loop, and then I'm going to do something with that. Okay, but this time, I'm not just going to be looking at the data, I'm actually going to be looking at a special kind of structure called a range. And in this case, Python has 6 letters, we'll just do range 6. What range is going to do is going to give me the indices 0, 1, 2, 3, 4, and 5. All right, and I'm going to call these indices just I, short for index. And I'll print these out. Print I. And now, so I left my original code up here, so it's still printing out Python. And then I'm gonna, let's just actually print a new line right here so they're spaced out a little bit. That looks pretty good. Okay, so then when I print the indices, I've got 0 through 5. And that's great because now the other thing I would like to do is be able to say, you know what? I've hard-coded Python right here. Let's go ahead and just change this to word equals Python. And then instead of using the word Python, I'm going to go ahead and leave it right there. I could replace that with word, but instead I'm going to use word right here. And I want character, well, first 0, and then 1, and then 2. So, and I'm just printing them out on the same line. And again, these are just individual characters. I'm using indexing into a string, and indexing gives me 1 character. So I'm going to multiply that by 3. I wish it didn't shrink that box on me. I've got to resize it every time it runs. Now I've got the 3 P's, the 3 Y's, the 3 T's, and so on. All right, I changed my mind. I'm going to go ahead and put in word right here. Hard coding is just not good. If I want to change my example to pythons or pythons are snakes or something like that, that's going to make this much more interesting. So this first example, I'm going and doing all of the letters in this data. Pythons are snakes. In the second example, I hard-coded the 6 here. So not such a great thing to do. So what I really want to do, I'm going to change it back to Python. We'll fix that in a second. I'll leave it that. We'll fix it back to Python in a second. Is not hard code the size. What I'd really like to do is know how many letters are in this string. And there's a function for that. We talked about it a little bit. That's just going to be length of, and then I named my variable word, even though there's more than one word here, singular. But it's going to get the job done. So now I can see that I've got 18 letters, 0 through 17. So that's 18 total letters. In fact, print length word. What does that give me? Yeah, that's going to print out that 18 right there. Okay, perfect. But now it's no longer hard-coded. It's going to adapt and print out the entire string. I want to keep this a little shorter. So Python, now it's changed the length to 6. We do have 6 letters. All right. So let's explore what's going on here a little bit more with range. So I've got range of something. I'm just going to go ahead and print this out. We'd see what it looks like. I'm using Python Tutor because it's going to give me all sorts of extra information over here on the side as we run the code. In this case, this is a special kind of data in Python called a range, and it's going to give me the starting value 0, ending value 6. All right, and a moment ago, I actually, actually it's still right here. I'm printing out the indices generated by this range function. So we can think about this as the data structure or the data, just like when we were going through data here and grabbing one character. Here, this is a data structure that's going to be giving me one piece of data at a time. And those pieces of data are just numbers, 0 up through whatever number I've put in here. So I've got a version that looks like this. There's 2 other versions of range. Let me just put them in comment mode here, so you can see so this will do the numbers 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Okay, we also have the version that starts with a starting number, an ending number, and that will print out 2, 3, 4, 5. And it's just like the indices, when we were slicing, the first one is inclusive, the last one is exclusive, so it's not going to do the 6 here. Let me just demo that real quick. In fact, I'm just going to copy and paste this loop. I don't need to print out the word 3 times. I just want the index. And right here, I want 2 through 6. And now I can see I'm getting 2, 3, 4, 5, just like I predicted. All right, I'm going to leave this. Actually, I'm going to put each one of them in. So if I only give it one number, it gives me 0 through 5, but not the 6, because that 6 is exclusive. It starts at 0. It's giving me 6 numbers. I can put in a different starting number if I want, so I can start at 2, stop at 6. And then there's a third option too. Suppose I only want like every other number. I can put in an increment. So this is going to be start, finish, and increment. So that's going to be this one right here, 2, 4. It doesn't include the 6. It starts at 2. Second number, we add this. So now we have 4. And then for the third number, we would add this again. We see it's a 6. That's too big. So we just get the 2 and the 4 from this version. Maybe this would make more sense if I had like 11 or something. And then I can see I'm getting 2. Can't see it because it's tiny. 2, 4, 6, 8, 10. When it gets to 12, 12 is too big. It's bigger than 11, so it's going to stop. All right. And just to be complete here, if I wanted to do the same thing with a while loop, I certainly can. In that case, I'm going to need a while loop, while something. There we go. And this is going to, hold on here. Let me get some more space. Scroll that up. All right, we need a loop control variable. So we'll have, let's go with I equals, we'll start at 0. And while I is less than the length of word, then we need to I plus equals 1. All right, there we go. That's sort of the minimum we need for a while loop. And now I can use that I for an index. And I have a line up here. This one. This is the exact same thing we've got to do. So I'm just going to paste that in right here. And now, let's see here. In between all of my examples, I went back when I pushed pause on the recording and put in print statements, a blank line between everything, and a little comment about what I'm actually doing. Here, let me show you what I mean. So I've added all these comments. So this is the range 6, 0 through 5. This is the start at 2, go up through 6, but not include 6 right there. This is the one with the increment. And this will be the while loop version. So there it is. All right, so we had 3 different versions. Just quick recap. This was the first one, just 2 lines, grab each character in the data word. This is the one, your first choice because it's the simplest. If you need the index, then we can't use this. This is not going to work. We need something that gives us an index. So this is our second choice, the range for loop. This will give us the index. We can still easily grab the data we need. It's not quite as concise as just, the letter C, but I can use the index and the data to grab the piece of data that I want. And then for the maximum in versatility, I need to go with the while loop. This is going to be even more writing, a little bit more difficult to keep track of, but it gives us everything we need all in one loop. All right, what I want to do next is just walk through this a little bit. So first thing I'm going to do is create the string word, store the text Python in that, and then I'm just going to go through these first 2 and compare them as what Python is really doing. When I get to this loop for C in Word, the next thing it does is it's going to create a new variable. Remember, we saw 3 different ways that we can create variables. You can just do assignment like line 8 right here. We can use the loop, or we could use a parameter in a function. So this creates a variable C and is going to grab the first letter and stick it in that variable. So it's getting the letter P. Then it's going to go down and print out C 3 times. So PPP. Then it goes back to this for loop and checks to see, are we done with the word? If not, grab the next letter. So it's going to assign, whoops, I didn't realize that, drag them around. It's going to grab the Y and assign that to C. Gets updated right there. Then it's going to print that out 3 times. And it goes back to check to see if it's done. It's not. It grabs the T and stores that in C. So right here we now have upgraded that variable C to a T, and so on. So THON. All right, and then new line. Now this next version, what we see is we're going to create a new variable right here, I, and it's going to get the value 0. Okay, so this is going to give me a list of numbers. Then we go through, it's going to grab and print out the 0. It's going to go and index into Python the word is Python, and grab the P. So this much will be P. And then it's going to print that out 3 times. So there we go. Then it goes back up to line 14, grabs the second number from this structure right here. You can think about range as just like a magic black box that, the for loop is going to say, give me the next number, give me the next number, give me the next number. And range just knows that it's going to give out the numbers 0 through 6 in this case. Well, 0, 1, 2, 3, 4, 5. Yeah, so then it's going to go through, it updates I is now 1. It's going to go through, print out I, print out the index 1, that's the letter Y, character from the word variable 3 times. All right, maybe one more time for I is now getting updated to 2 right there. And then it's going to go through, print out 2 and the letter, the third letter in index 2 position 3 times. All right, guys, I just have one more silly example that I want to do. It's going to print out another silly example, and then what we're going to go for is to create the letters Python with the first letter on one line, the first 2 letters on the next line. On line 3, we want 3 letters. Line 4 gets 4 letters. Okay, so the most simple version of the loop, the for C in Word, isn't quite going to do it here because we need to keep track of how many times we want to print out everything. So I'm going to go with the range loop here, and this is a great opportunity to use slicing instead of just indexing. So we could use a double loop and just go through and print out the first letter, then the first 2 letters, and the first 2 letters. But Python gives us that cool slicing feature, and we should take advantage of that. So here's the idea. I'm going to be using for, and then something in something. There we go. And then I'm going to do something with it. And what I'm going to be doing here is a range style loop. So I want range. And I do want it to begin at 0. So all I need to do is put in the maximum length. And that's going to be length of word. There we go. And now, because these are giving me numbers, I'm going to use them as indexes. I'm going to call them I for index. A lot of people use IND or IDX, something like that. Now, what we want to do here is print something. And what we're going to be printing out is word. And we're going to slice this. So we're going to use brackets. We're going to start with the very first letter. Here, in fact, I can just put that in, 0. And we want to end at, let's try I. I don't think that's exactly what I want. Let's see what it looks like. Need parentheses. All right, now that should be enough to see some. Okay, so I've got another silly example here as my header. Then I have a blank line that I didn't type. Then we've got P, PY, PIT, and it stops here. This is the bottom one. We're missing that last letter. So what's going on here is I'm actually trying to print out, and let me just do one more line here. So we'll print out some stuff so we can see the next line. And then we'll print out word. The first time through, this is going to be a 0. I is going to be 0 the first time through that loop. So when I do this, when I print out, when I spell, print word 0 to 0, it's going to say, okay, grab the first letter. It's got to be less than the final letter, so it prints nothing because this is exclusive. So it's got to meet both of these criteria. It's got to be bigger than this one and less than that one. Bigger than or equal to. Bigger than or equal to, less than that one. So it prints nothing. That's why we saw this blank line right here. It's why nothing got printed after my gibberish line. It prints nothing. So what I really wanted was not 0 here. When that was I was 0. I want one more than that. So let me go ahead. I'm going to delete this experiment. And go back right here and put in I plus 1. And now this should be good. So the first time through I is 0, but I do want to print a character, so I need I plus 1. The last time through, I don't want it to stop when I get to number 5, because range is going to go 0, 1, 2, 3, 4, 5. I want to print out the entire word, so 0 to 6. And that 6 is exclusive. All right, also, since I'm starting with 0, I don't actually need to explicitly say 0. I can shortcut that. Just a quick reminder for you guys that that's totally an option. All right, let me jump back over to the slides and we'll start talking about lists. So the first 5 weeks of the course were about control flow. And the second 5 weeks of the course are really going to be about state. We're going to start talking about data. This is, what does the program know? What variables does it have access to? And we talked a little bit about this. We've already been using variables for a number of weeks now. Think about the Battleship game, though. The Battleship, we had something like, 8 rows and 10 columns, or the other way around, something like that. And we had enough data there so you could play one round of the game. You could guess X and you could guess Y. But that was only one turn. If you wanted to record like all the possible guesses that a player could make, we need a guess X and a guess Y for every single peg on the board. On an 8x10 grid, that's 80 pegs and 2 variables, X and Y per peg. That's something like 160 variables just to keep track of where the user guessed throughout a Battleship game for all possible games that you could play. That's way too much. So what we really want is to be able to hold more pieces of data, but not use more values. Or maybe we want to, and that's kind of the purpose of a data structure. We want to hold more values. I think I said that wrong the first time. More data, not more variables. So data structure is going to hold more values. They're going to be organized in some kind of way. And we'll just have like one variable to refer to that entire structure with tools that let us access the values inside. So today we're going to be starting to talk about lists, which are a great data structure. The next one is dictionaries. But between the two of those big ones, that's the majority of the next couple of weeks. And there's a couple others that we'll bring up also. So to begin with, a list, a mutable sequence that can hold anything. We just think about this as a bunch of boxes all in a row that we can put values in. Because they're sequences, just like strings are, we can do a lot of the same things we can do for strings. Indexing, slicing, we can go through with a for loop. We can use length, we can use in, we can concatenate the multiplication. I'm going to demonstrate all of that stuff today. I'm going to come back and talk about mutating and switching between strings and lists at the end, but that's kind of the plan. So today, as we get started, I'm going to compare what we learned about strings, because they're sequences, and bring over the things that are in common from strings to lists. And let's just dive into that red line right there. All right, so a string is just a sequence of characters. I've got a bunch of boxes all in a row. In a string, they have to hold characters. So I've got hello world here. This is the same example we had from last week. And I've got 3 things demonstrated here. I can access one value with indexing. Here, S with the brackets 1. So S of 1 is going to give me the character E. I can slice out or extract a subsequence. So in this case, this would be S of 6:11 would give me world, or 6:-1, because I don't need that last character. Or we can use a for loop and just go through every single character and do something to it. All right, just a couple of examples as we walk through this. So I've got a message, hi world here. Quiz yourself. If I do message of 1, and that's how you read the brackets of. So I might say brackets 1, I might say of 1. But the idea here is that we're going to be, okay, make a guess, write it down, commit. Did you guess I? All right, remember they start at 0. So H is going to be message of 0. I is going to be message of 1. Let's do another one real quick. Message of 3. All right, what do you guys think? Did you guess W? And we have to count the spaces. So H is 0, I is 1, space is 2, W is 3. Okay, so that's indexing. We're just grabbing one character. Let's talk about slicing for a second. So slicing is going to get us a sequence of characters that are all in a row, basically a substring. So if I start with 3, this is going to give us the entire world with the exclamation point, because the colon means go all the way to the end. So 0, 1, 2, 3, it starts with W, all the way to the end. If I do this one, 3 to -1, remember we can use negative indices, but they're just going to start counting from the back of the string and move forward. So this is going to be -1, this will be -2. These indices, when we're slicing, the first one is inclusive, So 0, 1, 2, 3, we will include the W. It goes all the way over. The -1 is going to be this exclamation mark. We are not going to include that. That's exclusive. So this is just going to give us world when we do that slice. All right, and then if we use the for loop, you get these dots if you're using like Python in interpreter mode. I've got them here. So if I have for character in message, this is what I just did with the word Python in my range like pre-demo. Just printing it out, it's going to go through and grab each character one at a time, print it out on its own line. All right, so the question that the list answers for us is, what if we have data that are not just characters, but I want to do something like this? I've got a bunch of boxes all in a row, and I want something that's like a number or a Boolean or something else. So the answer in Python is we use a list. It can hold any kind of item we want. All right, so check this out. When we create a string, it's got to start with a quotation mark. It ends with a quotation mark. I've got a sequence of characters in there. It doesn't actually have to have any characters. It can be an empty string. So this is the syntax to create a string. All right, when I create a list, I also have syntax I need to follow. These are the rules that Python needs to be followed so it understands that I'm creating a list. The first one, it starts off with a square bracket. Then I put in my values, but they have to be separated by commas. The commas can either come between or after, or another way to say that is everything gets a comma separated list, but I have an optional comma at the end. I can put one here or not after the 33. And then I've got to close this up with the brackets so that Python knows that I'm done creating my list. So rules for creating a list. I need square brackets. I need commas between my data items. And I can put pretty much anything I want in a Python list. All right. So go through those same three things. I can index, slice, and access with the for loop. So here I've got nums. When I create lists, typically I will try and use plural variable names for lists because they can have more than one thing. When I index into this, if I get num0, that's just going to grab the very first data item, in this case the 22. If we grab nums -1, again, it can count backwards from the end. So this will be the -1, that'll be -2, -3 index. So -1 is going to give me 33. Exactly the same way with strings. So this is great. If you've got strings, the lists are going to be easy. Same deal with slice. Whoa, hold on. I'm not quite done with indexing. All right. I wanted to point out one really common, confusing thing for new programmers. And that's that we are now using brackets in two different ways. So check this out. In my line right here, nums equals, I'm using a bracket to say we are creating a list. Hey, Python, this is a list of data. Use the list stuff. So I've got my opening bracket right here. I've got my data. Then I've got a closing bracket. I'm going to just rewind a second. Over here, this black bracket, I'm using this black bracket to index. So I'm using bracket right here to create a list, a bracket right here to index. And Python knows the difference because it looks at what comes right before this bracket. If there's the name here, in this case, if there's the name of a list or a name of a string, it knows that this is indexing because it's following some sort of data that can be indexed. If that's not the case, in this case it's the assignment operator and equals, it knows that it's creating a brand new list. So here I've got two different kinds of brackets. In fact, let me color code them a little bit. The green brackets here are creating a brand new list. There is nothing to the left of that green bracket to indicate that I'm indexing. So Python knows it's creating a list. This red bracket over here follows a list because Python it reads left to right. It knows it just created a list. So it knows that this bracket is used to index. So I've got two different kinds of brackets. It can be very confusing if you're new. It's something you get used to though, so trust me. You'll probably get confused if you've never seen this the first time it comes up. And then you'll figure it out. Be like, oh yeah. It also makes really good quiz questions. So best of luck with those. All right. Next up, slicing. We can still slice just like we can with strings. So in this case, I'm going to be grabbing from item 1 all the way to the end. Remember, it starts at 0, so we're going to skip to 22. Item 1 is inclusive, so that'll grab the 11, and then the 33. And Also, this one's kind of interesting. If I choose a number, so I've got, in this case, 0, 1, 2, there is no item 3 to include all the way to the end. Python is just going to do return an empty list. It's not going to give us an error. It's just going to say, okay, your list, none of these are valid, so it's an empty list. Was unable to transfer any valid items to the new list. All right, and then finally, just like we could with strings, for loop is just going to be the same syntax for, in this case, I'm using x, their numbers, in nums, print them out. It's going to go through and print out the first one, the second one, third one, each on their own line. All right, so real quick, I'm going to pop over to Python Tutor and just write a function that's going to add up a list of numbers. We're going to have a list containing floats, and it's going to produce some of those numbers. It's going to look something like this if I use it from the Python interactive mode. So we'll give it a list, we'll add them up, and then prints out the answer. All right, before I get started, I still have all of this code over here in Python Tutor. I grabbed all of it and I put a link to this exact demo. It'll be in the description, so you should just be able to click the link. It's actually, if you just generate permanent link, anyone can do this. You can create a link to your code. You can send me things that you've done in Python Tutor. Anyway, I've done that. It's in the description if you want to see exactly what I've done here. Otherwise, I'm going to nuke it. Okay, so the next thing I'm going to do, I'm going to just write a function that adds together a bunch of numbers. So in that case, I need some numbers. And I'm going to create a brand new Python list. So I need the square brackets. When I type, I tend to put in both brackets right away. And then I'll left click over and start putting in my data. So let's add up 1.1. Let's focus there for a second. 1.1, a comma separated list. So we'll put in 2.3 and then 5.4. That should be pretty simple. 1, 2, 3, 8.8 it looks like. All right, so now I've got my list. Next thing I'm going to do is define a function. Let's call this add nums. All right, this add nums needs to take a list of numbers. In this case, I'm just going to call it nums. It'll do some stuff. I'll come back and fill that in a second. And then I'm going to call the function add nums. We'll give it nums and we'll print it out. So right now the function prints, it doesn't do anything. It doesn't return a sum at all. Instead it just passes, which means it does nothing. So this is printing out none because I don't have a return yet. Here, let's upgrade this. Let's return 0. Now it should print 0. Okay, that's obviously the wrong answer. We need to fix that, but it's something. So we're passing in a list of numbers. Let's go through, we're going to need to go through the entire list and do something with them. So let's get started with that part next. So here we go. For something in, and my data here is nums. It's a list. I'm going to make it plural because I've got more than one thing in here. And I'm just going to, how about we just print them out? Print, and then I need a variable name. Let's go with n. It's going to grab the first item in nums, the 1.1, store that in n, and then we'll print it out right there. All right, let's just check and see that this is working. So I'm going to go back to the beginning, first line. It's going to create this variable, nums, and store 1.1, 2.3, 5.4 in it. Check this out. Python Tutor actually is going to display all the numbers. It's going to show me the indices. That's great. Next thing, I'm going to define the function, so it's going to remember where that is. Then we're going to call the function, so it's going to jump in. It's going to say the parameter here, nums, that nums right there, because this is in the add nums frame, is going to point to this list. So it's going to have the same numbers that are in nums. So I've got two variables that are using the same list. All right, next thing, for n, so I should be able to, yep, there it is, there's my n. It's going to get a copy of this first item on the list, so 1.1. Then I'm just going to print it out right there. Next time through, n gets updated to 2.3, prints it out. Then n gets changed to the 5.4, and we print it out. All right, so that's kind of how that works. Now, instead of printing them, what I really want to do is return the total. So as I go through, I'm going to have a running total, and I'm going to start that off at 0. And then instead of printing the numbers, I'm just going to say running total plus equals n. All right, cool. So then as I go through, next, running total, it gets the sum of all these, 8.8. I don't actually want to return 0. I want to return the running total at the end of this. Got a blank line there, I don't need that. Clean that up, and jump to the end. It's going to print out 8.8. All right, so hopefully that was clear. I hope I didn't go too fast for these guys trying to follow along at home. Pause the video if you need a little more time to catch up and make sure this works. If you want to do any experiments here, this is your chance while you're right here. If you have any questions, go ahead, post those on Piazza. All right, so just a couple more things that we can do with any sequence. That means strings and lists. All right, length, concatenation, in, and multiplication. So let's just go through this side by side. I've got strings on the left, lists on the right. The first one is length. We can compute the length of any string, the length of any list. So here we've got 3, 2, 1, go. That's got 5 characters in it. The length is 5. This list has a 99, 11, 77, and 55. That's 4 items, so the length is 4. Pretty straightforward. Concatenation. When we use concatenation with a string, 3, 2, 1, go, add exclamation marks to that message. It just extends the string and adds those extra characters. Remember, lists, sequences with concatenation are going to work exactly the same way. So if I have 2 lists, 99, 11, 77, 55, and I add 1, 2, 3, it's just going to tack those onto the end, and I get a longer list. For those of you guys used to vector math, if I have 2 vectors of the same length and I add them together, oftentimes we'll see element-wise addition. That is not what Python is doing here. It is not doing vector math. All right, next operator is in. We've already seen the in operator with the for loop, but this is just going to ask the question, is there a G in message? And there is, so this is going to be true. Same deal with lists. I can ask, is there an 11 in this list of items? Yes, there is. It's right there. That'll give me true. And finally, multiplication. Oops, I got 2 examples here. Is there a Z? No. Is there a 10? No. Both of those are false. Now multiplication. Okay, so in Python, when we talked about strings, multiplication here was really just the same thing as adding message to itself. In this case, twice. If we had a 3 here, it'd be message plus message plus message. So it's going to give us the same thing as concatenating the list to itself or the string to itself. So in this case, we just get 3, 2, 1, go, repeated twice, all in the same string. Again, when we do this with lists, we get the list just repeated twice. And again, those of you guys who are good with math, you've seen vector addition, vector multiplication. This is not what's happening here. Python does not do vector math with lists like this. Instead, it's just going to have 2 copies of the list, create a new list, and make it bigger. All right, so that was all of the things that strings and lists have in common. All of the sequence things right here: indexing, slicing, for loops, length, concatenation, in, and multiplication. Now, there are a bunch of things that strings have that lists don't have. These are specific string methods like find, replace, switch to uppercase, lowercase, formatting, those kinds of things. Lists do not have those. They're a lot more general. But what we will see is that we have flexible types, and I'll explain that next. And we're also able to change the data in lists. So that's known as mutation. That's coming up shortly. Strings don't have either of those available to them. They're forced to be characters, and you cannot change some of those characters. All right, so flexibility of types will be next. Here's the idea. I can have a list. They're just little boxes all in a row in order. They've got an index or a number associated with them, but I can put in any kind of data I want. So far, the data we've seen: strings, booleans, integers, floats, and even other lists. So I'm going to jump over to Python Tutor real quick. And again, I just made a copy of this code. There'll be a link in the description, so you can come back to that. So in this case, let's make a new list. L is equal to a list, and let's put in, let's see here, a string, a float, an integer, maybe 2 integers, there we go, and a boolean. in both of them. There we go. And this is just going to show me that I can put in every single one of those types of data. I can print it out. Print out my list. There it is. I've got my string. It's actually the word string. Number, integer, integer, float, boolean, boolean. All right, awesome. I'm going to upgrade this a little bit and just do, and let me make another, we'll make this L1, then we'll have an L2. I'm just going to add another list to this. And what I see here is that the last item in my list is actually another list. So let's talk about indexing for a second. If I wanted to grab this very first thing and print it out, pretty straightforward. I would grab L2, I'm going to use indexing, and I'm going to grab the first index, the 0th position. That's going to print out the string. If I want to grab the 3.14, that's at the index 1 position, prints out 3.14 right there. If I grab the last position, the -1, that's where this list is, it's going to print out the entire list, 1, 2, 3. The entire last item, which is a list. It's going to print the whole thing. While I'm thinking about it, the comma here at the end is optional. I can put it there or not. So I can think about either each data item having a comma after it or commas between. It doesn't matter. Python is good either way. Okay. Got distracted. Focus mic. All right. Now, suppose I wanted to print out the last item of the last item. So that last item is a list. I want to grab that 3 from that position right there. To do that, I'm going to print out, so this much right here, let me highlight this, is a list. And I can index straight from a list by just using more square brackets. So I'm going to grab those, we put in the square brackets, and if I want the last item, that's another -1. All right, so I hope that was pretty straightforward, at least with my explanation. If you need to hear that again, pause the video, rewind about a minute, and play that last minute over again. And while I'm in the middle of demonstrating stuff, let me just real quick print out the length of my list. And we'll talk about this for a second. It's giving me 7. Okay, so I've got the string, that's 1. The float is 2, 3, 4, 5, 6, the 2 booleans, and one more list makes 7. So it's giving me all of the sort of top level list pieces. So here it is. 1, 2, 3, 4, 5, 6, and then 7 is that list. It's not counting all 3 of these as separate. If I wanted to do that, that's known as list flattening, and we'll be getting there in perhaps a couple, maybe 2 or 3 more weeks. If I knew that the very last item here was a list and I wanted the length of that, all right, this much gives me the first list, the top level, and then I would just grab the last item, and this should print out the 3 now because there are 3 items, 1, 2, 3, in the list that's the last element in my L2 list. All right, back to PowerPoint. All right, next up we're going to talk a little bit about mutability. So mutating means we're changing something. So if something is mutable, that means we can change it. If it's immutable, that means it's unchangeable. Now I'm going to tell you right now that strings are immutable and lists are mutable. So we can change lists, but we cannot change strings. You're probably thinking, wait a second, Mike. I know that I have seen you change strings. In fact, the very last lecture you did, you were changing a string. All right, let me just flip to the next slide here. And we need to be really careful here. So it's about the values being changed, not the variables. So variables can always be changed. Let's take a look at this leftmost column right here. I've got lists on top and strings on the bottom. Lists, and in all of these cases, I am like creating a brand new list and assigning it to a variable. Here I'm creating a new list, assigning it to a variable. So I'm setting a variable to a new value. That is always allowed. In fact, I'm doing it here with strings. I'm creating a string AB and assigning it to a variable. So S gets AB. Then I'm creating a new string, CD, saying S gets CD, assigning that to the variable. I can actually do the plus equals. This is going to take CD, with a value stored in S, it's going to plus E to it, do concatenation. That generates a brand new string, CDE, and we'll assign that to S. And in each of these cases, we lose the data that was in the string before the reassignment. So this is setting a variable to a new value. All right, that's not what I meant when I said we can't change the strings. This is changing a variable. Okay, so here's what's going on when I change an existing value. So here I'm going to be digging into the list or into this string. So in this case, I've got nums here, 229, and I'm going to try and get and access the second number. So I want it to be CS 220. We always use 220 for any kind of number example. But this is wrong. We're not 229. We need to go in, grab that 9, and replace it with a 0. So in this case, nums2 is going to be 012. The 9, this is allowed. I can change this list. I've got that data element, the 9. I can change it by just indexing and assigning it a new value. This is absolutely forbidden with strings. If I have string 229, I am not allowed to change it. So S2 does index that character. It gets the character back, but it's immutable. I cannot change it. All right, guys, I'm going to jump back over to Python Tutor now and talk about ways that we can change lists or ways that we can mutate them. One sec. Okay. I'm going to nuke this stuff, and then I'm going to create a new list. Let's call it L equals 624. That's what I really meant. Okay, there we go. Now I have a small list. Now, I'm going to talk about a couple of ways we can change the list. The first one is just known as updating. And this is just going to be using indexing or slicing. In this case, I'm going to grab the L0. And we'll change this to an 8. I can see over here in my global frame after this code is run that it's gone from a 6 to an 8. So it's 624, now it's 824. So this is just known as updating. All right, next up, if I want to add more data to the list, this is known as appending. In this case, we can just type the name of the list. It's a method, so L dot, and it is a list method. What do you think? How about a 9? So I do L dot append. That's going to add a 9 to the end of this. This can be a little bit tricky because if I do L append, it's a function, so I need those brackets, parentheses. If I add a list to it, so let's put in, 3, 5. What I see is that it's actually appending an entire list as item at index 4, the 5th item. If I wanted to add a bunch of items all at the same time, that's known as extending. So append and extend are very similar. This one adds a bunch of items. Append adds one item. Maybe a list. All right. So quick demo this. Let's go with L dot extend. Give it some square brackets. We'll put in a list. In this case, we'll do the 3, 5, 7. So now I can see I still have that 4 there. The 4th item is a list, but now I've added 3 more items. So 3, 5, and 7 at indices 5, 6, and 7. All right, hopefully that was pretty straightforward. Update, add more data, and then removing stuff. Remove data from the list. So the easy way is just pop. So L dot pop. This is going to grab the very last item and remove it. So here, let me do this. Print L. So that'll print out a copy of my list. I'm going to pop from it, and then print L again without any typos. And we can see that it's removed the very last item. Perfect. That's so pop is always going to do that. It's going to grab the last item, take it out. And if I want to, I can store this in a variable. And then we can print out the variable. And we can see that X now contains that. So let me just X equals, there we go. Looks good. Maybe a space. Looks really good now. Okay. Now pop can also be used with an index. So L dot pop, And now if I want to get rid of this list, that was at index 0, 1, 2, 3, 4. So I'll just pop index 4, and then we'll print the list again. And we see that it's gone. If I store this in x equals that, so that'll replace the 7. I can print this out again and see that x now contains that list that was popped. All right, finally, one more cool feature, sorting. This one is really straightforward. I take the name of the list. It's a method, so I'm going to use the dot and then the name of the method. The method name is sort. Give it some parentheses, and it's going to go ahead and sort that list for me. Now check this out. If I print out L after sorting, it actually modifies the list. It's not creating a new list and returning it. It's actually sorting it in place right there in the data structure. So 2, 3, 4, 5, 8, 9. If I want to preserve a copy in the original order, I need to go ahead and make a copy of that list. And we'll talk a little bit more about copying lists in upcoming lectures. All right, I want to wrap up with transforming between strings and lists. There's a lot they have in common. And we've got two methods we're going to learn. They are split and join. They're both string methods. So in this case, if I've got the string a quick brown fox, and I take the name of that string and use .split on it, that method, it takes a separator. In this case, I'm using the space. It's going to break this into a list. So it's going to read the first character, find the space. This will be the first item in my list. It's going to be the word A. Then the second item in the list at index 1 will be the word quick. It finds another space. This is going to be the third item. Brown finds another space, fox. So it's basically creating this list of strings. All right, and then going backwards, the join method is also a string method. So it's going to take a string, .join, and then as far as the how it's called, and then this takes another argument. This is the list that we'll be joining together with this separator in between all of them. So take a second, think about what joining these sequence of letters, this list of strings, with the separator I is going to give us. And here's a hint. This is actually a picture of my hometown. I'm from La Crosse, Wisconsin. With 800 people in the class, there is almost certainly someone else out there from La Crosse. This is the Cass Street Bridge, home of the Big Blue Bridge Blues Blast every summer, at least while I lived there. I haven't lived there for a while. I don't know if they still do it. But this bridge spans what river? Here's your hint. And the answer is the Mississippi. All right, one quick little detail here. I did have to put this extra blank string here because the I is a separator. So it's going to go in between these. M-I-S-S, right here, I-S-S, I-P-P. And then in order to get that very last I in Mississippi, I needed to have something to separate. And I wanted the empty string because I don't want more characters. The last letter in Mississippi is an I. If I were to leave that out, then I get Mississippi. And that's not spelled right. I'm a horrible speller, but that one I just can't stand. All right, so next up, one final demo for today. Suppose Piazza's getting a little crazy and everyone's frustrated about how terrible the exam experience was, and we're starting to see a lot of bad words appear. Well, I don't want to have to go through and change all the bad words myself. I want it to be done automatically. So what we're going to do is write a function that takes in a string containing profanity, and we're going to return a new clean string where the profanity has been replaced with stars, right, like that. All right, so let me jump over to, I think we'll do this in Python Tutor. One sec. All right, guys, I just jumped over to Python Tutor. We're going to start writing this. First, we need a function. I'm going to call the name of the function Censor, and it's going to take in a string. A string containing bad words. Let's call it dirty string, and we'll go ahead and clean it. Then let's see. Right now we'll just pass. Here we'll print the string and just see what we got, and that'll be the end of the function for now. So then we need an actual string. Let's call it a message, just use a different variable outside the function. Let's see here. We'll say messages. OMG, that exam was so remember your recording mic, it's going to be on the internet, buggered. There we go. Let's throw in some exclamation marks. And leave those out. We'll just leave it like that. I don't need that much emphasis. It wasn't that bad, was it, guys? Okay, all right. Anyway, then let's just try calling this censor message. And when we run this, if I didn't mess up by putting that there, it should print out that exam was so buggered. Okay, looks like this much is working at least. So instead of printing it, I think instead I'd like to return it, because we're going to be cleaning this up. If you guys ask, yep, return does not require the parentheses. I just pop those off. And instead what we'll do is clean equals the return message, and we'll print out the clean message. There we go. Should be still good. All right, looking good. Now, we're going to need a couple things. We're going to need to go through each word in the dirty phrase and do something to it. We need to know if it's bad, and if it's bad, then we need to replace it. So I'm going to break this down into a couple of steps. We're going to take that dirty string and we're going to split it. And we're going to split using the space. Okay, this is going to return a brand new list, and it's a list of words. So let's call it words. Some will be good, some will be bad. And then let's just go through and print them all out just to make sure that things look good. So we'll go for W in words, print W. And now this should print out all of the words. What did I do wrong? Oh, there it is. That exam was so buggered. And then this is printing out the clean one, this last line right there. Okay, so now, next thing I need, we need a list of bad words. Let's go ahead, we'll just put this up at the top. We'll make it the first line of the function. We don't need it outside the function. It doesn't need to be global. So we have bad words. All right, what are some common bad words? Let's see, we'll make this a list. Let's see, how about OMG? How about shucks? Darn. Buggered. All right, oh, after this week, exam. We're putting exam on this list. All right, let's call that good. And we can add more. You know, you guys use other words that some people might find offensive. We can add those later. All right, let's see. So now I've got all these words. Instead of printing them out, what I really want to know is, let's print out just the bad ones. So if, and I can say W in bad words, this will be true if the word is in this list. In that case, I want to print it out. So let's see here. If we just run to the end, OMG, exam, and buggered, all in the list. Okay. I wonder if buggered has 2 R's. Anybody know? All right, nope, that's spelled correctly. All right, so at this point, what I want to do is once I've identified bad words, I've actually got 2 choices here as to how I proceed. The first one would be to try and replace them with the stars. And the second approach would be to, every time I go to a word, I either add the word to a new list of words or I add stars to the list of words if it's bad. So I've got 2 choices here. In the projects, you guys will be doing both of those. Just remember, you've got options. I'm just going to show one of them right here. And the one that I'm going to demonstrate is the replacing. So if I want to replace something, if I get to a W and I know that it's wrong, I actually need to know, where did that come from? Was it the position 0, position 1, position 2, to replace that? So this is not the right kind of list to make that replacement, not the right kind of for loop. I really do need the range style for loop. So I'm going to go ahead, I need to change 2 lines. So instead of W, I'm going to be getting an index. So I'm going to change this to I, for I in range length of words. So now that will give me 0, 1, 2, 3, up to all of the words. There's a problem here. I no longer have a W, so this should give me an error if I ever run this. So instead what I'm going to do is say W equals words of I. And now this should all be good. Let's just run the code again. See, I'm getting exactly the same result. All right, now I have the index where that bad word is. So if I find a bad word, instead of printing it out, and we'll keep that for a second, printing it out, what I can do is I can go back and say words of that position equals, we'll place it with a star. All right, then, yeah, that should be, so I'm returning the original string right here, so this should actually just be printing out, yeah, let's go to the end, the same thing. So I haven't actually changed, I changed this list of words, but I'm not returning that, I'm returning dirty. So not quite what I want to do yet. What I want to do is create, let's see here, we'll create a new list, we'll call it clean. Oh, I've used that before, that's fine, that's fine. We'll put in the join, and the way join works, it's a string method. So it takes a string, and this is going to be whatever separator I want. Because I'm making a sentence, I want spaces between all my words. I'm going to send this with the string that's just a space. All right, then I'm going to be joining. It's a function, so I need the parentheses. And this function takes a list of things that I'm going to be joining together. It's a string function, so a list of strings. So in this case, words is my list of strings. So I'm going to be putting that together, mashing it into a brand new string, and we return this. All right, so let's see what this looks like. So next, last, there we go. So in this case, I can see that I've replaced all of the bad words from my sentence with stars. I don't feel like well, actually, let's leave that for a second. I can see this first bad word has 3 characters, and I've only got 1 star here. The second one has 4 letters. I've only got 1 star. So, I mean, the bigger the word is, I feel like I should replace it with more stars. So one of the ways I can do that is just use that multiplication. So here I've got words of I. I know the length of my word. It's length of W. So I'm just going to multiply it by, let's make this length W. And instantly it's updated. So now I've got 3 stars, 4 stars, and however many stars are in buggered. 8-ish looks maybe. All right, so let me check my notes. All right, guys, this is going to do it for me. Everyone have a wonderful day. If you're watching the live stream, I'll hang out and answer any questions you guys have. If you're just watching it on YouTube later on, go ahead and put any questions you have on Piazza or come to see us in office hours. And everyone have a great day.